Hi, this is section 4.2. Hopefully you've located your notes in the lecture packet, but I'm going to go over that step by step, and what we're going to do is we're going to talk about place value or positional value numeral systems. In particular, we're going to focus on the Babylonians. So before we learn how to change a number in the Hindu Arabic system or HA system, which is our system, into the Babylonian system, we have to understand how to write a number in expanded form. So the first example asks us to write 576 in expanded form. Okay, before I do this, I'm going to look at each digit, and the 6 is in the ones position, the 7 is in the tens position, and the 5 is in the 100 position. Okay, so when I write that up, I can expand this by saying 5 times 100 plus 7 times 10 plus 6 times 1. Okay? So that's how I would write up 576 in expanded form. If they want you to write it in terms of powers of 10, and the reason why I'm using powers of 10 is it's because what our numerical system is based off of. I would write this up as 6 times 10 to the 0 plus 7 times 10 to the first plus 5 times 10 squared. Okay? And I want to make a note. Anything raised to 0 power equals 1. So 10 to the 0 is 1. So that's how I get the value of 6. So that's writing this up in terms of, the powers of 10. So I'm just going to highlight the powers of 10. So if you use different powers, such as power 60, power 4, you would start with, for instance, if I'm using powers of 4, 4 to the 0, 4 to the first, 4 to the second, 4 to the third, etc. And I also want to tell you that the values 0 through 9 are considered digits. So if you hear the word digit, it's talking about these numbers that I'm writing up right now. So these are digits. Okay, so let's go on to objective number 2, which is Babylonian numerals. So it is the oldest known place value system, and it was created by the Babylonians in 2500 BC. And their base system was base 60. I know that sounds weird to us, but if you think about it, a lot of things are in base 60, such as time. 1 hour equals 60 minutes. 1 minute equals 60 seconds, and so on and so forth. So some of the Babylonians base 60, blended over into modern day computational values. Also, if we think about 360 degrees in a circle, that can be kind of attributed to the Babylonians, but not entirely. So anyways, Babylonians are base 60. Okay, we have to keep that in mind. Okay, so their first position, or the ones position, is going to be 60 to the 0. 60 to the first is the next positional value system. So it's actually going to equal 60. So 60 to the first is 60. 60 squared means 60 times 60. So 60 squared gives me 3,600 or 3,600. 60 to the third power is 216,000. And then 60 to the fourth is 60 times 60 times 60 times 60. I get 12,960,000. Okay? I know I placed in your notes 60 to the 5th and 60 to the 6th, but really we're not going to have to convert anything that high, so that's why I just crossed them out. The other thing we have to know when we do the Babylonian numeral system, besides it's in base 60, is they used a couple symbols. They used this symbol here, which I call a spike, and then I have nicknamed this symbol a boomerang. Okay? A spike is equivalent to 1, and a boomerang is equivalent to 10. The reason why their symbols look like this is because they were using clay tablets, and they had this reed stylus. So the reed stylus, you just stuck it into the clay, and it made those shapes really easily. They did not have paper, So things probably weren't that easy to compute for them. Could you imagine having to carry around a clay tablet everywhere with you? It's insane. So anyways, no paper for the Babylonians, just the Egyptians and forward. There's one more thing that you have to know is they also had subtraction. And their subtraction symbol, whoops, so kinds of funny stuff going on here. Their subtraction symbol looks like a spike with a little tiny arrow on top. This means subtraction. Okay, so if you see that written in their numerals, it means to subtract. So let's go ahead and move on to objective number 2, which is to write a Babylonian numeral as a Hindu Arabic numeral. Okay, all right, so we start off here, and if we look at the first one, we have 2 boomerangs, and then we have 4 spikes. Okay, we noticed that, and I forgot to mention this, but with the Babylonians, to tell the difference between what place value in, they would leave spaces in between things. So we noticed that these values, these symbols are all jammed together. So that tells me that I only have one place value. And it's the first place value, which is 60 to the 0. Okay? So what I got to do here is I got to translate the symbols and then multiply it by 60 to the 0. So 1, translate symbols, and then 2, multiply that value by 60 to the 0, which remember 60 to the 0 is 1. Okay? All right, so let's translate. We have 2 boomerangs, so I know those were 10 apiece, so that gives me 20. And then I have 4 spikes. Remember, each spike is worth 1, so that's 4. So translation to that is 24. Now I take and multiply that by the base, which is 60 to the 0. So 24 times 1 equals just 24. Okay, let's do part B. We have 3 boomerangs. And then we have a spike with a little arrow on top. And then we have 1 spike. Okay? So let me just clean this up a little bit. All right, so I got to translate this. So 3 boomerangs, we know that's 10 apiece. So if there's 3 of them, that's 30. And then this means subtraction. Remember that symbol means subtraction. So this symbol right here is subtraction. And then 1 spike is just 1. So 30 minus 1 is 29. Since all the values are clumped together, I know I have 1 place value. And that's 60 to the 0. And remember, 60 to the 0 is the 1's place. So I'm going to take 29 times 60 to the 0, or 29 times 1, which will give me 29. Okay? All right, let's look at C. Part C, I have a spike, and then I have some space, and I have 2 boomerangs and 1 spike. And then I have a boomerang subtraction sign and 2 spikes. I'm going to leave these open just because it'll be cleaner, okay? And I have to translate it. So in the first place value system, 1 spike is just a 1. And now I have 2 boomerangs and a spike. So 2 boomerangs will give me 20 plus 1. So that's 21. And then I have here 10 minus and 2 spikes is 2. So that's 8. Okay, so the 1, or I should start at the base here. At the end, we have 8, which is in 60 to the 0 power. The next place value, since there's a space, is 60 to the 1st power. And the next place value over is 60 to the 2nd power. Okay? So I got to multiply these values by the appropriate power. So I have 1 times 60 to the second plus 21 times 60 to the first plus 8 times 60 to the 0. Notice how my powers are increasing if you're going from right to left in order, okay? So it's always 0, 1, 2. If I had another value system, then I'd put 3. So let's go ahead and figure this out. 3600, remember, is 60 to the second power, and let me write that down. And I'm going to multiply that by 1. So 1 times 3600 is 3600 plus. Now I have to do 21 times 60 to the first. 60 to the first is 60. So 21 times 60 is going to give me 1,260 plus 8 times 60 to the 0. 60 to the 0 is 1. So 8 times 1 is 8. So basically I have to add 3,600 plus 1,260 plus 18. And when I do that, I get 4,878 as my answer. Okay, we have one more. We have D. So let's do that. I keep on hitting that button on accident. Okay, so I have a boomerang, and then I have a spike, and then I have some space, and then I have 2 boomerangs, and then I have the subtraction symbol, and then I have 3 spikes. Okay, so let me make sure I wrote that down right. Yeah. All right, so if I translate the first one, I get 10 plus 1, which is 11. And the second one, I get 20 minus 3, which gives me 17. Okay, the 11 is in 60 to the 1 power. The 17 is in 60 to the 0 power. So I write down 11 times 60 to the first power plus 17 times 60 to the 0 power. All right, so let's figure out what 11 times 60 is. And if we multiply those two together, 11 times 60 will give me 660. Let me just check this really quick because I actually made a small mistake. Okay, I was right. It's 660. Plus, now I have 17 times 1, which is going to give me 17. So 660 plus 17, if you put that in your calculator, you get 677. Okay, so that's what that translates into. All right, now we are on to a new objective. This is going to be objective 2. And we revisited that chart. So basically we have 60 to the 4th, that is equivalent to 12,960,000. And then we have 60 to the 3rd, which is equivalent to 216,000. 60 squared is 3,600. 60 to the 1st is 60. And 60 to the 0 is 1. Okay, so this is a translation into actual values. So this next objective is we're going to start out with our Hindu Arabic numerals, and we're going to go to a Babylonian. So we're going to translate to a Babylonian numeral, okay? So if we're going from our system to theirs, we are going to divide, okay? And you're going to use this a lot in the next section because we have to use bases that are not base 10. So going from ours to someone else's, it's harder, it's division, okay? So I'm going to go over the steps. I'm going to read these to you, and then we're going to do A, B, and C. So steps to converting from base 10 to any other base. By the way, this is in your notes. Write down the values of each position in the system and find the value that is closest to the Hindu Arabic numeral but does not exceed that numeral. 2. Divide the Hindu Arabic numeral by that value. 3. Take the remainder from step 1 and place that value under the division sign. Now divide the remainder by the next positional value down from the first one. If the remainder is too small, then place a value of 0 and drop down to the next positional value system until you get to the ones position. Keep on repeating step 2 and 3 until you reach the ones place value of the base you're converting to. The last thing we have to do is state my answer. So if I have to state it in Babylonian, I'm going to have to use the boomerangs and spikes. So let's go ahead and see this in live video here. So the directions for part A, B, and C say to write the numeral as a Babylonian numeral. Okay, and we start off with the Hindu Arabic numeral is 243. So the first thing I tell you to do is write out the base value. So 60 to the 0 is 1. 60 to the first is 60. 60 to the second is 3,600. And just for the heck of it, 60 to the third is 216,000. Okay? Now, if I look at 243, the number that is closest, or the place value that is closest to 243 without exceeding it, is 60 to the first. Okay? So what I'm going to do is I'm going to take 243 and I'm going to divide it by 60. I'm going to make a little note over the side that I'm at 60 to the first so I can keep track. So that way when I get down to 0, I know to stop. Okay? Your next step is to take 243 and divide it by 60. You're going to notice you're going to get 4 point something. Ignore the point something and just put the 4 down there. Now you're going to take and multiply 60 times 4, which is 240, and you're going to get a numerical remainder, which is 3. Okay? You're going to take that 3, bring it down, and then we're going to divide it by the next base value down. The next base value down from 60 to the 0 is 60 to the, the next base value down from 60 to the 0, 60 to the first is 60 to the 0. Okay, so once again, we're decreasing until we get here. Okay? All right, so what is 60 to the 0? That's 1. So how many times does 1 go into 3? And hopefully you answered 3. So I have the value of a 4 and a 3. The 4 is in the 60 to the 1 place value system. The 3 is in the 60 to the 0 place value system. So I have to notate that in Babylonian. So 4, I notate that as 4 spikes. Okay, and I'll fill them in for fun. Okay, and then I leave a space because I have to drop down a position value, and I do 3 spikes. Okay, so this is my answer right here. 4 spikes, space, 3 spikes. Okay, and you can check it by reconverting back from Babylonian to Hindu Arabic like we did in last objective. Okay, let's do part B. So for part B, same directions, write the numeral as a Babylonian numeral, and it's 3,605. Okay, all right, so once again, write down each position. We have 60 to the 0, that's 1. 60 to the first, that's 60. 60 to the second, that's 3,600. 60 to the third is 216,000. Okay, I want the positional value that's closest to 3,605, and that's 60 to the second. So I'm going to use that. So I'm going to take my value, 3,605, and I'm going to divide that by 3,600. I'm going to notate over the side that I'm starting with 60 to the second power. Okay, so how many times that does 3,600 go into 3,605? Hopefully you said once. So 1 times 3,600 is 3,600. And we have a remainder of 5, okay? I have to drop down to the next position system, which is 60 to the first. So does 60 go into 5? Hopefully you said no, because 60 is too big. So what I do is I put a place value of 0 and I drop down to the next position, which is 60 to the 0. So 60 to 0, remember, is 1. So my remainder for this one is 5 again. So 1 goes into 5 times. So now I have to represent 1, 0, and 5, okay? So 1 is represented, remember this is 60 to the second, 0 is 60 to the first, and the 5 is 60 to the 0 power. So to represent this, I do one spike representing 1, and I'm just going to let you know that I'm skipping a place value because I can't represent 0, but I can represent 5 as 5 spikes. Okay, so there's my 5 spikes, and here is my answer. Okay, so if you have, a number that is too small, like 5, I can't divide 5 by 60, it'd give me a fraction, then you just drop down to the next position value, make sure you put the 0 placeholder. Okay, last one, part C. Part C says I have to convert 12,435 to a number, a Babylonian numeral. So once again, 60 to the 0 equals 1. 60 to the first equals 60. 60 squared equals 3,600. 60 to the third is 216,000. And we can see 60 to the third is too big, so I got to start here. So my first step is to take 12,435, divide it by 3,600. Once again, I'm notating on the side, I'm starting with 60 squared. And when I do the math, 3,600 goes into 12,435 3 times. It's 3 point something, right? So we forget the point something. We're going to multiply 3,600 by 3, and I get 10,800. Now I subtract. So I get 1,635 as my remainder. So I got to drop down to the next position value system, which is 60 to the first. So I'm taking 1,635 and I'm going to divide it by 60. Okay? 60 goes into that 27 point some times. So I'm going to keep the 27. I'm going to take 27 times 60, which is 1,620. Then I'm going to subtract, which I get 15. Then I'm going to take that remainder of 15 and divide it by the next positional value down, which is 60 to the 0. 60 to the 0 is 1. 1 goes into 15 times. Okay, now I got to represent these digits. So remember, 3 is in the 60 to the second power, 27 is in the 60 to the first, and then the 15th is 60 to the 0. Okay, so representing 3, it's 3 spikes. Next place value down is 27. I'm going to use subtraction. I'm going to make 3 boomerangs. And then I'm going to subtract 3 spikes. Okay? And I'm losing room. So this part is going to go down here. All right, so this last part, and I'll just make a circle to let you know that, that's what I'm doing here. Probably make the circle bigger. To represent 15, I'm going to use 1 boomerang and then 5 spikes. Okay, and that's what goes in that value. So my answer, just to make it a little bit nicer, is going to be 3 spikes, 3 boomerangs, subtraction, 3 spikes, that gives me 27, and then boomerang and 5 spikes. Okay, so there's my answer for part C, and we are finished with this entire section. Great job.